How can you represent a proportional relationship with an equation? Take this sponge, for example. This isn't a sponge from under the kitchen sink. It's a living sponge from the ocean. The sponge is an example of a filter feeder. That means it takes in food by filtering water through its body. The sponge maintains a constant flow of water through its body. This sponge filtered 8 liters of water in 10 hours. It filtered 12 liters in 15 hours. Using what we know, what equation can you write that represents the proportional relationship between the time and the amount of water filtered?
Before we write our equations, we have to figure out the constant of proportionality. So let's go ahead and review how a proportional equation will look like. A proportional equation will be in this format. Y equals mx, you may see it as y equals kx. There's several different forms for proportional equations. It could look like A equals B times C. It could look like part equals percent times whole. You'll see me use this a lot once we get into percent. But notice these are all proportional equations. So it has the same format. A variable equals something times something else. They're all in the same format. It is all proportional. You can have Q equal S times T. That is also a proportional equation. But let's go ahead and figure out what this proportional equation is for this problem. And we'll use this format, y equals mx. Now y, that is our dependent variable. Now I want you to write this down. Y is our dependent variables. X is our independent variables. And m, that is our constant of proportionality. You'll see me writing like this, constant of proportionality. And you will have the definition later on in this presentation. So in order to figure out our m, our constant of proportionality, we need to figure out the unit rate. And we'll use this 8 liters in 10 hours and 12 liters in 15 hours. In order to figure this out, we have to first figure out what is our y variable and our x variable. Remember, y is the dependent variable and x is the independent variable. Now, when we are dealing with time, it's easy to figure out which one is independent. Well, the hours in this case is the independent because time depends on no one or nothing. So time will always be our independent variable unless it specifies. So we are going to put liters in our numerator for our y and hours in our denominator for our x. So let's go ahead and work on the blue one. We'll put 8 over 10, and then let's go ahead and simplify that. They're both divisible by 2, so we'll end up with 4/5. Now let's simplify the green. We'll put 12 liters over 15 hours, and then we can go ahead and simplify. They're both divisible by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. So notice, they both simplify to 4/5. That lets us know this is proportional. Now that we know it is proportional, we can go ahead and write a proportional equation. We can write our proportional equation using our constant of proportionality, which is 4/5. Now this is how our equation will look like. Y equals, and we are going to substitute our constant of proportionality in for m, which is 4/5, and then we'll leave x. So this is our proportional equation based off of this situation here.
The constant of proportionality is the constant multiple that relates proportional quantities x and y. It is the value of the ratio y over x and is represented by k. Let's make a table to find the constant of proportionality. We'll need to track time, hours, and the amount of water filtered, liters, to determine the rate, liters per hour, the sponge filters water. Which quantity should be y and which should be x?
So remember, y is our dependent and x is our independent. And like I said before, time depends on no one. So that lets us know that hours should be our independent variable, which is our x.
X is the independent variable. Y is the dependent variable. The liters of water, Y, that flow through the sponge depend on the number of hours, X, that have passed. So, the rate, liters per hour, is Y over X. Okay, now let's use the data to complete the table. In 10 hours, the sponge filtered 8 liters of water. The ratio Y to X is 8 to 10, so the unit rate is 8/10 liter per hour. In 15 hours, the sponge filtered 12 liters of water. That's a ratio of 12 to 15, and a unit rate of 8/10 liter per hour. The ratio is constant, so the constant of proportionality, K, is 8/10.
Notice in this presentation, they wrote the constant of proportionality as a decimal, but when I did it, I wrote it as a fraction. Either way works because we know 4/5 is equivalent to 8/10. So here's another one. Well, what if hours was 5 and liters was 4? Well, notice we put Y over X, so we will do 4 over 5, and 4/5 is equivalent to 8/10. Now, if we do the same thing here, we put 16 over 20. They're both divisible by 4, so then we would simplify, and we would get 8/10. Same here, 20 over 25, simplify, 8/10. 24 over 30, both divisible by 6, and we will get 8/10. So this shows a proportional table because all ratios simplify to the same thing.
You can use the value of K to write an equation that represents a proportional relationship. Recall that the constant of proportionality is equal to the ratio of Y to X. Multiply each side of the equation by X. Rewrite the equation. Use the equation to represent the relationship between time and the amount of water filtered. Which variable in the equation has a value of 8/10?
Select your answer.
So remember, 8/10 was our constant of proportionality. So you have to look at this equation, Y equals KX, and figure out which variable represents our constant of proportionality. In this case, it is K.
Substitute 8/10 for K. Now you know how to write an equation that represents a proportional relationship.
Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. How does the equation change if the amount of grape juice is the independent variable, X, and the amount of apple juice is the dependent variable, Y?
The triad, we have to complete this chart, and notice they put Y over X, and Y is the grape juice and apple juice is X. So let's go ahead and complete this. So we are going to put 8 because that's our X, our Y value, and then 5 because that's our X value. Now we cannot simplify this, so let's go ahead and work on the next one. So we have 16 over 10. Now we need to make sure we always simplify, and these are both even numbers, so I know they are divisible by 2. Now 16 divided by 2 is 8, and 10 divided by 2 is 5. Notice they both simplify to 8 over 5. Both ratios simplify to 8 over 5, so this lets us know that this chart is proportional. In order to have a constant of proportionality, the table must be proportional. So this lets us know our constant of proportionality is 8/5. An equation that represents this proportional relationship is Y equals 8/5 X. Remember, our constant of proportionality is our K. You may see it as Y equals MX, and that will be our M. Now, to convince me, we have to figure out, well, how would it look if we switch the independent and dependent variable? Instead of this apple juice X being our independent variable, we're going to change this to Y, our dependent variable. Now we're going to change this grape juice to X, our independent variable. So now it will look like apple juice over grape juice. So let's go ahead and work that out. The first one, we will put 5 over 8. That's simplified, so let's move on to the next one. Then we will put 10 over 16. Remember to simplify. So when I simplify, I get 5 over 8. So this is also proportional. So to answer the question, how does the equation change if the amount of grape juice is the independent variable x and the amount of apple juice is the dependent variable y? So the equation would change because before it was 8/5, and now it would look like y equals 5/8x. So the constant of proportionality has changed. It looks like it's the multiplicative inverse.
1 inch equals 2 5400 centimeters. How many centimeters long is an 18-inch ruler? Step 1. Write an equation to represent this relationship.
In order to write our equation, we first need to know what our constant of proportionality is. In this case, K, our constant of proportionality, I'm just going to write COP, that means constant of proportionality. Y, remember that is our dependent variable, and X is our independent variable. And in this case, our independent variable is our inches. And dependent variable is our centimeters. So our constant of proportionality, to figure that out, we can put centimeters over inches. And here, inches is equal to 1 and centimeters is equal to 2 5400. So that lets us know our constant of proportionality is 2 5400. Now, in order to answer this question, we're first going to build our equation. And we did the first part to build our equation was find the constant of proportionality, which is 2 5400. So our equation will look like y equals 2 5400 x. Remember, y is our centimeters and x is our inches. So it's asking us, well, 18 inches equals how many centimeters? So in order to figure this out, we just need to substitute 18 in for inches, which is our x. So we are going to do 2 5400 times 18. Now let's go ahead and simplify. I'm going to do that math over here. And remember, when you are multiplying decimals, you do not have to line them up. 8 times 4 is 32. 8 times 5 plus 3 is 43. 8 times 2 plus 4 is 20. Add my 0 as a placeholder. I'm going to mark these off so I won't get confused. 1 times 4 is 4. 1 times 5 is 5. 1 times 2 is 2. Now I'm going to go ahead and add. That's 2, 7, 5, 4. Notice I have 2 digits behind the decimal point, so I'm going to move my decimal point over 1 2 times. So that means 18 inches is equivalent to 45 7200 centimeters.
A florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses, x, and the total cost of the roses, y. How much would 18 roses cost?
First, I'm going to annotate by highlighting my given and find. I know a dozen roses cost $35.40, and it tells us the number of roses is X, and then the total cost is Y. Now I need to figure out what I am trying to find. So the find is how much would 18 roses cost? In order to figure this out, we first need to figure out the unit rate, how much one rose costs. And we can do that by the same way we find our constant of proportionality, by putting y over x. In this case, it tells us y is the total cost. And the total cost is $35 and 40 cents. Now we can put that over X, which is the number of roses. Well, it tells us right here, a dozen. And a dozen is equal to 12. So that's 12 roses. Now I'm going to go ahead and simplify to figure out how much one rose costs. I'm going to divide the numerator and denominator by 12. 12 divided by 12 is 1, so I'm left with 1 rose. And then $35.40 divided by 12 is $2.95. So that lets us know one rose costs $2.95. Now we can go ahead and build our equation. Well, we know our equation should be in this form, y equals mx, or you could say y equals kx. Now, m is our constant of proportionality, or our unit rate in this case. So our unit rate, or a constant of proportionality, is $2.95. So we'll go ahead and substitute that in for m. And then x is our number of roses. So now we have our proportional equation, and we can go ahead and figure out the answer. Well, it asks us, how much would 18 roses cost? Remember, y is the total cost, and then x is the number of roses. So in order to figure this problem out, we will have to substitute 18 in for the number of roses, or 18 in for x. So $2.95 times 18 is $53.10. So 18 roses will cost $53.10.
Can you represent the total cost, y, for admission and x rides at the amusement park using an equation in the form y equals k times x? Explain.
All right, my total cost is y, and then the number of rides is considered x. Now I need to figure out what the constant of proportionality is to figure out if I can answer this question. In order to make an equation, this proportional equation, we must have a constant of proportionality. So we are going to put cost, because that is our y, over x, which is our rides. So the first one, that will be 25 over 1. And then the second one, we will put 30 over 2, and then we can simplify that. And that will give us 15 over 1. And then the last one, we could put 35 over 3, and that is the simplest it can go. So notice we have 25 over 1, 15 over 1, and 35 over 3. Those are 3 different unit rates. So this lets us know this chart is not proportional. That means we cannot write it in a proportional equation. In order to write it in a proportional equation, we must have a constant of proportionality. And this chart does not show a constant of proportionality. Here, the first one ride costs $25. 2 rides cost $30, which the unit rate is $15 per ride. And then the third one, if we ride 3 rides and it costs $35, that's $11.67. So this relationship is not proportional.
Balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons rise at a constant rate. Which situation can you represent using an equation of the form y equals k times x? Explain.
In order to answer this question, we first need to figure out the constant of proportionality. And to do that, we are going to put y over x. But notice this question doesn't tell us which one is the y and which one is the x. But what I said previously in this lesson, time depends on no one. So if it doesn't specify, time will always be our independent variable, which is x. Now the other one, the height, is y. So now I'm going to go ahead and simplify the first chart. That will be 9 over 1, which simplifies to 9. And then the next one will be 13 over 2. which simplifies to 6.5. And then the last one will be 17 over 3, and that is 5 6/10 repeating. So notice we have 3 different answers. In order to make a proportional equation, we must have a constant of proportionality. This is not a proportional table, so we cannot use this. Now let's go ahead and go to the next one. We're going to put y over x, so that will be 4 over 1, which simplifies to 4, and then 8 over 2, and we know that simplifies to 4, and then 12 over 3 simplifies to 4. So we have a constant of proportionality, and the constant of proportionality is 4. So that means we can build an equation for balloon B. So our proportional equation is, remember, K is our constant of proportionality, and we just figured that out here. So our proportional equation will look like y equals 4x.